I finally figured out what William Lyne describes in the Paul Scarvo interview. Scarzo, excuse me. Scarzo interview, when he said how he took two antique meters and he thinks he wired them backwards or something, and to meter an apartment. And the reason why he has more than one isn't because he wanted to subdivide. Well, maybe it was because he wanted to subdivide his metering of that apartment into two different branch circuits, but to accommodate that, he's using antique meters from a junkyard, so he got them for free, or practically nothing. And in ancient times, a century ago, namely, meters were not designed to handle large loads such as we have today. Like, I think right now we're expected to run 30 amps and 120 volts, or 240 volts and I think 50 or 60 amps. 60 would be the limit. Anywho, 100 years ago, they expected you to have a 5 amp load in your home because all you were running were light bulbs. That was about it. So, he might have said that he reversed one of them. I can't remember if he said, did he reverse both or reverse one of them? As it turns out, you do reverse one of them. You put them in parallel with each other. So you got the incoming line, you split it into two branches, and then you rejoin those two branches to feed the apartment. That's right. So he put 2 meters because he was trying to accommodate the fact that the apartment wasn't subdivided into 2 different branches. He simply did not want to buy a meter. He wanted to get them free from the junkyard. They're old, and because they're old, they're designed to accommodate lower loads, and so he needed 2 of them in parallel to cover the combined load, because that's a current division situation. But here's the catch. Because they're in parallel, each is in reverse relative to the other, is wired in reverse, which is not an issue if all we think about is the electrical connections. But what if, see, he doesn't remember all the details, so he couldn't, and he said that, he admitted that to Paul during the interview. He only stated what he remembered. Now, I'm picturing it in my brain. Okay, you have them wired in parallel, and they're either back to back or facing each other because each is in reverse to the other. From the standpoint of going around the circle, when you have 2 items like that connected, and there are 4 terminals basically, and because they're in parallel, it's a current division situation. If you go around the circle and ignore the direction of the AC coming in one end and going out the other end of this circle, but just paying attention to the circle itself, and you go around the circle, you see that each is in reverse to the other, so that the terminal, the line connection for each are connected together, and the load terminal for each are connected together. That makes each backwards relative to the other. But because the dominant energy, see, he didn't expect them to be generators. You would never do that if you had a generator, hooked up, because they'd knock each other and they'd hum, because these are single-phase induction motors, I think. Or they could, they're induction. In other words, they need a starter coil to get them going. but they may not be because of the way they're designed. By comparison to the single-phase induction motor, let's say, of an ice cream kitchen machine, ice cream maker. But whether because I know that in the kitchen appliance, you need starter coils to get it going. Otherwise, it just hums. It'll vibrate without starter coils. But it shows that is still in evidence, regardless of whether or not meters do have starter coils. I think they do have starter coils, now that I think of it. So that means they're capable of humming without the starter coil. What he's talked about, humming, vibrate, just shook the building. So when you have them facing back to back, the starter coils are too weak an influence, I guess, to get the thing to rotate, and instead it just vibrates. And he said that was when the load reached a certain critical point, like a tipping point, in which it stopped metering and started going in reverse if the load went beyond that, increased beyond that. But if it was below that, it would just function like a meter. So it became distorted when it reached a certain critical point. And that's when it hummed, because it couldn't meter anymore. The distortion was so great that the discs stopped running, they stopped spinning, and they vibrated in both directions simultaneously. Because each became the generator for the other. Each was the motor for the... If each was the generator for each other when the other was the motor. So each saw each other serving opposite roles, depending on which direction the vibration was occurring, going one way or going the other way. One was acting like the motor and the other the generator, or vice versa. And this is the classic phenomenon of little kids thinking, well, why don't I just connect a motor to a generator and I'll have free energy if I connect them in a closed loop. And this is exactly what you do, because you've got an AC signal coming from outside this circle and then passing through, going out the other end to your true load, because this is just your generator motor pair, and it's not your load that you're trying to carry. So being that it's in a tight loop, most of the current's going to stay inside the loop. Now that I think of it. That means that these little devices cannot generate, they can accommodate a higher voltage, but coming from outside, but that doesn't mean they can generate a higher voltage. So they have to be overwhelmed by the voltage coming from the grid in order for the grid to dominate the situation. I wonder what would happen if the voltage dropped from the grid and all you were left with was the 60-cycle signal, sine wave signal, but divested of its 120 or 240 volt input. And instead, you'd have, I don't know, a fraction of a volt or something. That could be interesting. Because then I would suspect that's what creates the tipping point in the first place. Well, no, wait. Let's see. Loads in the home are all in parallel. Right. So, with each other and with respect to the meter and with respect to the source, for that matter. Just as these two meters were in parallel. No. No, it's a different kind of parallel. No. The loads are all shorts. That's it. They're in parallel with each other, but they're actually 90 degrees to the arrangement of these two meters. So you can't call them... you can't call them current division. They're voltage division. No, they can't be voltage division. Oh, what are they? No, they are current division. What? Which is which? Oh my God, I am mixed up. They have to share all the same voltage. So they'd have to be current division. But then why are the 2 meters current division? Oh God, I am really mixed up here. So what are the meters? I'm sorry. I have to complete my thought as to why I started this recording in the first place. So what William Lyne left out of the picture, what he could not remember, was that because they either face each other or face away, I think they faced away from each other. They were back to back, and he even put them next to each other. Now, after the I-10 General Electric meter was produced, the meters that came after that, I think it's the I-14, did not have a cast iron backing into which the iron toroidal core was set into, the core having the voltage coil on it and the current coil for the meter. Instead, they had an aluminum backing, I believe. From the pictures on eBay, that's what it appears to be. And I know that's the case from the 1935 model. I don't know what model number it is, but that was the time that it was date stamped when it was produced. It's an all aluminum construction, I believe. There's no iron other than the pieces that need to be ironed. There's no extra iron. Certainly no iron back pieces. What that would have done, it would have helped be that iron mass, maybe, that Tesla was referring to, that retains or helps to promote the magnetism of the core, namely the circularity, the pathway it takes. And transferring that to the other meter behind it that's turned around in reverse means that one would be destined to run its disk backwards and the other one forwards during one half cycle, and then they would reverse if the magnetism was strong enough. The magnetic field that's being transferred, that's magnetically coupled between them. And it would fight itself, and it would hum violently. I can see that. But they have to be magnetically coupled strongly enough, which means the load has to draw enough current from the grid to magnetize their backsides sufficiently enough for them to hum and fail to rotate and fight each other. Now, if the load is increased, now we're talking very vaguely here. We don't even know what kind of load we're talking about. Is it an inductive load, resistive load? Doesn't matter. Well, the way William Lyne tells the story, it's so vague. It seems like it doesn't matter, but that's, neither here nor there because we don't know. Maybe it doesn't matter. Maybe it's just current draw. How much current do you draw from the electric grid? So if you draw more current, but see, the only way you can draw more current, you can't do it with a resistive load. If anything, you'd be increasing your resistance. So it would have to be an inductive load, whereby you're creating more shorts, because each coil is a short. So he increased not just any old load. He would have had to have added inductive loads. And that would have created more shorts for more current to flow. So he'd be drawing more current, and that would increase the magnetism of the backside of the meters to the point that they would hum, and they'd stop metering and stop accurately measuring his how much he's drawing from the grid. And then if he keeps increasing those shorts by adding more inductive loads, now he's drawing so much current from the grid. I guess what happens is the 2 meters lock. They no longer fight each other. So that when, let's see, they'd have to dominate. They'd have to take over, but the voltage is still dominant. The voltage coming from the grid is still dominant. And that's the signal. That is... So the meters can't generate high voltage. All they can do is generate current. And probably only because they're in a closed loop with each other. The load certainly is not going to generate current, or does it? If it's an inductive load that he's adding to draw more current, now we have to wonder whether or not the loads are consuming current. See, he didn't state the whole thing because he didn't scenario it in his brain. Well, he left out the putting them back to back for one thing. Yeah, you have to wonder where all the extra current is coming from that went back to the grid. Was it coming from the loads? And why? In a sense, you could say that the 2 meters each becomes the prime mover for the other. Each becomes the motor for the other, depending on which half cycle you're in. I guess when you're at the balance point, the humming point, they can't decide which is going to be the... They have to decide which is going to be the motor and which is going to be the generator per half cycle of the sine wave oscillation that's coming in from the grid. They have to make up their mind. And if they can't make up their mind, that's probably why they hum violently. But when the load gets strong enough, the magnetic field, the coupling between them gets strong enough, and then it's almost a random choice, or it may not be random. There's always discrepancies, minor detail discrepancies that we overlook, like the manufacturing, one is slightly different than the other, or their connections favor one over another. So whatever it is, they end up deciding which is going to be the motor and which is going to be the generator per half cycle. But that's a signal decision. That's not a power decision. I'm thinking that possibly the load becomes the generator because it's drawing more current. See, that's one thing about the grid. It's large enough that the voltage is constant. It doesn't drop. Just because you add more loads in your home, unless, everybody does it, and then you get a brownout and then a blackout because the voltage drops. But if it's within reason, the voltage maintains itself regardless of all the loads you keep adding in your home, and you keep drawing more and more current, and yet the voltage remains the same. Oh boy. Well, so that strengthens the coupling between the 2 meters. I guess they're the ones. They're taking turns during each half cycle of which one is generating and which one is consuming. But that doesn't tell us why it goes to over unity and becomes a contributing factor, because he said when the load increases, so if you keep adding more load, it means the little meters are generating more and more current, and probably would fry themselves if you took them too far beyond what their carrying capacity was capable of carrying. Gosh, it's still well, it's not still a mystery. It's just, how come nobody ever thought of this before? Because nobody ever thought of constructing a single-phase induction motor in the manner of a meter so as to be able to put them back to back. You can't do that with normal single-phase induction motors, such as what's in the power tool, like a drill, a power drill, or an ice cream making machine, because their design is completely different, the way they arrange everything. But in a meter, you literally get a front side and a back side. Oh. Yeah. Well, let's put it this way. In the single-phase induction motor that I took out of an ice cream machine, the rotor, the spin plane of the rotor is in the plane of the toroidal armature. And instead of two coils, such as a meter has arrangement, the coil is just one coil. And it's where the current coil should be. Instead, it's the voltage coil. It's serving in both capacities, I guess. Because the way it's wound is a voltage coil, but where it's placed would make it a current coil. And that's really bizarre when you think about it. Because normally you have to subdivide your functionality of voltage and current in order to be highly efficient, and that means those motors are wasteful. Whereas a meter has the coils separated, and they're arranged in 90 degrees to each other. And the rotor of a meter is its spin plane is 90 degrees relative to the plane of the toroidal core of the voltage coil, current coil. So the meter is actually more efficiently built, because it's got voltage at 90 degrees to current instead of mixing it all up. And then to make up the difference, the starter coils that are in the power tool, single-phase induction motor, and the ice cream making machine, the starter in the ice cream making machine, the starter coils are askew. They're not really efficient because they're at 45 degrees to the direction of travel that you want to induce in the rotor. And the rotor is a squirrel cage rotor, whereas in the meter, you just have a disc, an aluminum disc that's perforated to help catch, I think it's to catch the eddy currents, catch the magnetic field, to create sharp edges. I don't know, I forget. Voltage points on those sharp edges. In any case, it's a much more efficient motor, yet it cannot carry torque. It cannot deliver torque because of why? Oh, because the voltage coil is on a stub coming out of, or going in towards the center of the toroid, coming out from the periphery, pointed inward. and that's at right angles to the flow of current going around the armature. So you don't get any power out of it. The power has been neutralized, and that's the whole point. It's not supposed to contribute any power in the form of voltage. It's not supposed to contribute any voltage. It's supposed to be, like invisible or transparent. It tries to be It tries to be transparent with regard to voltage. The only thing that's not transparent is the current, and that's what you're measuring, I guess, ultimately, because that's the only part that's going to vary that will change your watts usage. So that makes sense. So the voltage is made to be invisible. And that's probably why you can put them back to back, because of that feature. It was built to be voltage invisible, so that they can engage their magnetic fields and fight each other. Because that's essentially the manner of this arrangement when you put them back to back and they're connected backwards relative to each other. They're going to want to magnetically couple at some point when the current gets strong enough, and that's going to cause them to fight even stronger than before. So in order not to fight, they're going to have to take turns each half cycle and decide who's going to be the motor and who's going to be the generator. At that point, they have to make that decision. Up to that point, they don't have to, because the force coming in from the grid is dominant. But when it no longer dominates the situation, when the load, I guess you take the load beyond the design characteristic maximum that the meters were rated for, is what you end up doing. So they would overheat and risk burning off the insulation on the wires. I guess so. This is very interesting. Now, there's still the anomaly that Jim Murray talks about, that when you double the voltage, when you double the frequency, you quadruple the power. The voltage would remain the same. That means the current is quadrupled. So if you were to change say you have this setup, and instead of going about the situation by increasing the load, what would happen if you simply doubled the frequency of the line coming in and kept the load the same? Does that mean you are quadrupling the power that you are delivering? Quadrupling the current? Making it harder for these generators to, or for these pair of meters to become a motor-generator pairing. See, that's the other thing that William Lyne misses. Because of the lack of his detail of the magnetic coupling of them being arranged back-to-back, they're two cast iron pieces immediately adjacent to each other. He misses the point that they're taking turns in which one is the motor and which one is the generator per half cycle of the signal that's coming into the situation from the grid. But why would you have current coming out of the situation going back to the grid unless the inductive loads that he added that drew more current became the generator? They'd have to. They'd have to generate current, and yet still rotate without... Yes, whatever happens to your... Oh my God. How can that be? And what does it mean when an assistive torque gets sent back? Well, the meters are sending out a voltage signal. You mean they normally don't? Well, no, because the voltage is supposed to be invisible. Now all of a sudden, they're sending out a voltage signal that's strong enough to continue to act as a prime mover. I think that's ultimately what it boils down to is it's not just an increase of current. The meters must be putting out a gradually increasing voltage signal to their signal that serves as the prime mover, because that's what represents the prime mover in the system, is voltage. And current is the drain upon that prime mover, essentially. And so how much current can the prime mover deliver will be predicated upon the strength of its voltage. Ultimately, I would assume the way to look at it maybe not. Maybe that's not the way it works. Because the only thing you're increasing in the system is the current draw. I guess, I know it sounds bizarre, but I think the only way to look at this is to assume that when it hums, they're equally matched, because one is the motor for the other, and the other is the generator for the one during each half cycle. But when it goes beyond that point, the only other way to analyze this is to assume that the inductive loads that he added that supposedly would be drawing more current are functioning as generators at that point, even though they spin. And that would present the case that the system the load is becoming its own prime mover, which doesn't make any sense. Tell me about it. Good God. Oh, God. But under authority to the meters. So the meters are authorizing the loads to become their own prime movers. See, that's essentially how you have to look at things. There has to be an authority. Usually it's a capacitor. So then I have to assume that the 2 meters are serving as a temporary storehouse of voltage in order for them to become the authority to authorize the loads inside the home to become generators of current. Because that's usually the way it works. When coils generate current, there has to be an authority nearby. And in this case, it's the 2 meters that are back-to-back, magnetically coupling with each other, and yet they're in electrical reverse formation to each other. That's interesting because now it changes the way I analyze what a generator is. A generator does not generate power. It's the prime mover behind it in combination with the generator that generates power. So the prime mover itself doesn't generate power, and we know that, right? Falling water at the dam doesn't generate power. But the generator itself cannot generate power either. And so what happens is the generator represents the generator of current, while the falling water represents the voltage that drives it. And that combination creates the generation of power. That's really the way to analyze what's happening, let's say, at a hydroelectric power plant. In the case of a coal-fired plant, it's the heat represents the voltage. Because even though the water is accelerating as it falls, it's ultimately not transferring that acceleration to the blades of the turbine that spin the generator. It's the pressure when they hit the blades, and that pressure is the voltage. See? It even translates. Look at that. Because we always think of voltage as pressure, right? In the case of heat, heat is pressure. I mean, well, it has an impact on pressure, let's put it that way, because pressure and temperature are closely linked. Are they indirectly or directly? They're directly linked, so that when one goes up, the other goes up. So you've got this heat affecting the pressure, essentially, of the system. And that's right. It boils the water, and that increases the pressure. Yeah, in a coal-fired plant, they have to boil water with the coal, the burning coal. Right, and that increases the pressure because that's what's driving the system. So ultimately, it's always pressure. Yet, you could say heat is what put the water in the stream in the first place, because it evaporated and moved around. Well, it gets resupplied, that's right. Well, but then it cools, so that doesn't really help. May not cool, it doesn't have to cool, but it does have to heat in order to rise and from one place to be able to transport into the new place. Whatever. I think that's a little too far removed, too remote to be of any use. No, forget about the heat. It's just pressure, basically. Ultimately, it's pressure that drives the turbine that spins the generator against its resistance, its magnetic resistance, to generate current. So it's really a two-part process. So the prime mover is not the whole story, and neither is the generator the whole story. They're two halves of the coinage of wattage. And once we have these 2 meters back to back, taking turns, which one is the motor and which one's the generator per half cycle, we have now duplicated within those pair of meters exactly what's going on at the power plant. See? This is why he couldn't understand or couldn't explain it, because you really have to thoroughly analyze the situation. And the crux of it all, for me, the turning point, the aha moment, is the fact that what if he put them back to back and they're wired in reverse relative to each other because they're in parallel, trying to satisfy the requirements of the AC input and the load output. So they have to be wired back to back in reverse to each other, but they don't have to be hung together to sit against each other. And they certainly don't have to have a cast iron backing to help promote the transfer of the magnetism from each of their two toroidal cores. So this is why it has to be a cast iron backing to the meter, and it can't be aluminum. And on the I-10, it's there's enough. Well, it's all cast iron on the backside, yet it's aluminum on the front. And that means that anything generated internally is going to be reflected back into the back piece. You see? So the I-10, it was specifically designed to do what William Lyne was describing. But you have to have two of them, and they have to be hung back to back against each other. Of course, if you built it that way in the first place, as a single unit, you would increase efficiency because the two back pieces would be one solid piece with a toroid on either side, and the magnetic transfer would be maximum. But the way it is, it's kind of iffy, and so since it would be maximum, you'd have generation of power right away. You wouldn't have to wait for the load to increase, the inductive load to increase your draw of current. I don't understand how a resistive load would draw more current, though. Because 100 years ago, all they had were light bulbs. Well, there you go. Even though these meters were built to accommodate a certain situation, the situation did not exist at the time, unless somebody had the foresight to realize that things are going to shift and people are going to start having motor loads. Oh, wait a minute. Industry always had motor loads because they had assembly line, conveyor belts. Ooh. So this is one way for industry to cut their power bill and cut their cost for manufacturing. Whoa. So even though it was intended for the home, it doesn't sound like it. It sounds like it's intended for industrial use to cut their costs. Yeah, well, what kind of cost is a residence? It's nothing by comparison to what industry has to fork through the nose, literally pay through the nose, because it's using a humongous amount of energy. If it's an assembly line situation or whatever, anything of that sort where you've got motors running, that's now that makes sense, because they didn't have compressors in refrigeration, I think, 100 years ago, 113 years ago, when the I-10 this particular I-10 was made, mine. I think it was stamped 1910, if I'm not mistaken. So now that starts to make more sense. So I guess I've said enough. I've gropingly mapped out what the situation is. So yeah, I think it's just so cool. All this knowledge is so cool.